So this is problem 3.5. It gives a spin 1/2 particle, and it has a moment at time t equals 0. It gives the state of the particle as this. So first it asks the probability of finding the different possible spins at time equals 0. So it's a half spin. So there's only two possible spins, either plus or minus h bar over 2. And it asks for the probability of each of those spins. And so the probability of ket plus spin, it can be written out as 1 over square root of 2 plus, 1 over square root of 2 times ket plus of x plus minus ket of x, and then so we just find the modulus of that for each of them. And so for a plus h over 2, it's just going to be 1 over square root of 2 squared, so it's going to be 1/2. For the minus spin, it's going to be 1 over square root of 2 squared. So both of them have a probability of 1/2. So next, it gives us a uniform magnetic field B equals B naught y hat, and it asks to calculate the state of the system in the SZ basis after time t. So here's our magnetic field. The Hamiltonian for this is going to be H equals negative mu dot B, and then this can be rewritten as negative G over Q 2M sub E times S dot B, and then S dot B is just, for our problem, is B naught S hat sub Y. And then we can rewrite this part, the negative G times Q over 2ME B naught, and just rewrite that as omega naught. And then so the Hamiltonian is omega naught S hat sub Y. So next we have to express the initial state, which is psi 0. You can't see it here because of the glare, but this is psi 0 in terms of the energy eigenstates. And so psi of 0 for this equals plus ket, and then that equals plus ket sub y, and then all of this. And then we solve this out to get this, and we can rewrite that as I over square root of 2 ket y plus negative I over square root of 2 minus ket sub y. And then the last step for this part is to multiply each eigenstate by e to the negative I e to the nt over h bar. So when we do that and substitute in our energies, or our eigenvalues, we get the final answer is I over square root of 2 e to the I omega naught t over 2 plus ket y plus minus I square root of 2 e to the negative I omega naught t over 2 minus ket y. So, and then next for part C, it asks to find the probability of the plus h bar over 2. So our probability is calculated with this equation right here. And so we want to find the plus spin, and so this can be expanded out by putting in psi of t, which we found in the last part. So we put in our answer from part B, and then now we just have to simplify this or solve this out, and eventually it simplifies down to 1/4 times I e to the I omega naught t over 2 minus I e to the negative I omega naught t over 2 squared. And so we can use our knowledge of complex functions and rewrite this into a sine function, and it turns into negative 2 sine omega naught t over 2, and then we square that, and so the 4 cancels out when this negative 2 gets squared, so we're left with our probability of getting a plus h over 2 is sine squared over omega naught t over 2. And then the last step is just asking for a drawing of what we did for part B and C. So here's the beam. It's going through a Z filter, and we look at the plus spins as they pass through a magnetic field B, and then they pass through an X filter, and then the probability of getting the plus X is just this right here. And so the probability of the up spin is sine squared over omega naught t over 2.